For over a century, our understanding of the physical world has rested upon four pillars, the four fundamental forces of nature. We have gravity which holds the stars together. Electromagnetism which powers our technology and binds our atoms. And the strong and weak nuclear forces which govern the hearts of those atoms. These four forces explain almost every interaction we see, from the falling of an apple to the fusion in the sun. But in the late 1990s, we discovered a cosmic anomaly that these four forces simply cannot explain. We found that the universe is not just expanding, but that its expansion is accelerating, pushed by an invisible, repelling energy that makes up 68% of everything in existence. We call it dark energy ***. For decades, we have treated it as a property of space itself, but a radical new theory is gaining ground in the halls of theoretical physics. What if dark energy isn't just a constant? What if it is a fifth force of nature ***? To understand why we need a fifth force, we have to look back at the shock that redefined astronomy in 1998. At that time, most scientists believed that the expansion of the universe, which began with the Big Bang, would eventually slow down. Gravity, acting like a cosmic brake, was expected to pull back on the galaxies, perhaps eventually causing the universe to collapse in a big crunch. But when teams of astronomers looked at distant type Ia supernovae exploding stars that act as standard candles, they found that the light was fainter than expected. The galaxies weren't slowing down. They were racing away from us faster and faster every second. It was as if you threw a ball into the air, and instead of falling back down, it began to accelerate toward the clouds. This realization forced physicists to introduce a placeholder to the equations, dark energy. The simplest explanation for this acceleration is the cosmological constant, a concept first introduced and then discarded by Albert Einstein. In this view, dark energy is a property of space itself. As the universe creates more space, it creates more energy, which pushes the expansion further. It is constant, unchanging, and perfectly uniform. However, this explanation has a massive problem. When we try to calculate the value of this vacuum energy using quantum mechanics, the number we get is times larger than what we actually observe in the sky. This is the greatest mismatch in the history of science. Because of this vacuum catastrophe, many physicists believe that dark energy isn't a static constant at all, but something more dynamic, a field that can change over time and space. This is where the idea of the fifth force comes in. In ancient Greek philosophy, Quintessence was the fifth element, the pure substance of the heavens, distinct from earth, air, fire, and water. In modern physics, quintessence is a hypothetical scalar field that permeates the universe. Unlike Einstein's constant, quintessence is a dynamic force. It can be stronger in some places and weaker in others. It could have been dormant for billions of years and then turned on recently to push the galaxies apart. If dark energy is quintessence, it effectively becomes a fifth fundamental force. This force would have its own unique properties. While gravity is always attractive, this fifth force is repulsive. While the nuclear forces only act over tiny distances, this force acts over the scale of the entire cosmos. It is a cosmic repulsion that is currently winning the tug-of-war against gravity. If there is a fifth force pushing the galaxies apart, why don't we feel it here on Earth? Why doesn't it push your coffee cup away from you? This is the central challenge of the fifth force theory. If it exists, it must be screened or hidden in regions of high density, like our solar system. One leading theory is the chameleon field ***. Just as a chameleon changes color to match its environment, this fifth force changes its mass depending on the density of the matter around it. In the dense environment of Earth or the Sun, the force becomes heavy and its range becomes so short that it is virtually invisible. But in the vast, empty voids between galaxies, the force becomes light and long-ranged, allowing it to push the universe apart. Scientists are currently performing incredibly sensitive experiments to find this hidden force. They use vacuum chambers and ultra-cold atoms to see if there is any tiny, unexplained push that can't be accounted for by the four known forces. So far, the chameleon remains elusive, but the search is pushing the limits of our experimental technology. Another way to look at the fifth force is not as a new energy, but as a flaw in our understanding of gravity itself. We call this *** modified gravity ***. Einstein's general relativity has been tested and proven correct many times. But almost all those tests have been done within our solar system, or with relatively nearby stars. It is possible that on a truly cosmic scale millions of light-years gravity doesn't work the way Einstein predicted. Some theories suggest that gravity leaks into extra dimensions, weakening its pull over long distances and allowing the expansion to take over. If this is true, dark energy isn't a thing at all. It's just the result of gravity behaving differently than we expect. In this scenario, the fifth force is actually just the real gravity that we haven't fully understood yet. Why does it matter if dark energy is a constant or a fifth force? Because the answer determines how the universe ends. If dark energy is a constant, Einstein's, the universe will undergo *** big freeze ***. Galaxies will move further apart until they are invisible to one another. Stars will run out of fuel, and the universe will end in a cold, lonely darkness. But if dark energy is a dynamic fifth force, and if it becomes stronger over time, a scenario called *** phantom dark energy ***, the ending is much more violent. This leads to the *** big rip ***. As the fifth force grows in power, it will eventually overcome gravity at every scale. First, it will tear apart clusters of galaxies, then individual galaxies, then stars, then planets, and finally the atoms themselves. Every structure in existence would be shredded by the sheer power of the expanding vacuum. The hunt for the fifth force reached a fever pitch in 2024, with the first results from the ** dark energy spectroscopic instrument, DESI, ***. DESI is mapping 40 million galaxies in 3D to measure the expansion of the universe with unprecedented precision. The early data from DESI suggests something startling. Dark energy might not be a perfect constant. There are hints that the density of dark energy has changed slightly over the last few billion years. If this is confirmed, it would be the death knell for Einstein's cosmological constant and the strongest evidence yet that we are dealing with a dynamic fifth force. It would be the most significant discovery in physics since the discovery of the Higgs boson of Vasa, sign that our four-pillar model of the universe is incomplete. There is another mystery that points toward a fifth force, the *** Hubble tension ***. When we measure the expansion rate of the universe, the Hubble constant, using the cosmic microwave background, the light from the Big Bang, we get one number. But when we measure it using nearby stars and supernova, we get a different, higher number. This discrepancy isn't a mistake. It's a crisis in cosmology. It suggests that something happened in the history of the universe that our current models don't account for. A dynamic fifth force, one that was early dark energy in the beginning and changed as the universe grew, could be the missing piece of the puzzle that resolves this tension. The idea of a fifth force changes how we perceive the universe. If the expansion of space is driven by a dynamic field like quintessence, it means the universe is not just a clockwork machine running down. It is a dynamic, evolving system where the laws of physics themselves might change over billions of years. It suggests a universe that is alive with fields we are only just beginning to name. It reminds us that we are still in the dark ages of our understanding. Just as the discovery of electromagnetism transformed the 19th century and the discovery of nuclear forces transformed the 20th, the discovery of a fifth force would define the 21st century. It would open up new questions about the origin of the Big Bang and the possibility of a multiverse where different fifth forces govern different realities. The quest to identify dark energy as a fifth force is the ultimate frontier of modern science. It is where the very large of the cosmos meets the very small of quantum fields. Whether it is a chameleon field hiding in our shadows, a leak into a fifth dimension, or a dynamic quintessence field, the answer will rewrite our textbooks. As we look toward 2026 and the full release of the DZ data, alongside new observations from the James Webb Space Telescope and the upcoming Euclid mission, we are on the verge of a revolution. We are looking for a fingerprint in the cosmic map, a tiny variation in the expansion that will tell us if the four forces have a younger, more powerful sibling. The universe is telling us that it is more complex than we dare to imagine. Dark energy is the elephant in the room, a force that moves galaxies and shapes the fate of time itself. If it is indeed a fifth force, it is the master of all others, a silent hand that has been guiding the expansion of the universe since the beginning. We are the first generation of humans with the tools to see that hand. And as we reach out to touch it, we might find that the nothingness of space is actually the most active and powerful force of all.